It's that time again. It's Sunday, 6 p.m., and you're here at Steve's Place. This week we'll have Mark Sokol, who's with the Falcon Space and affiliates who concentrate on lab-ready theories that have not been fully investigated. Um, but first, just a quick word or quick reminder about our YouTube memberships here. Exclusive memberships are bargain. For only $9.99 a month, you have access globally, 24/7. Anybody can get a YouTube. You have access to hundreds, close to 1,000 uh, videos at this time and growing every day. I would like to point out we also have the Global Sciences Congresses from back in the 80s and 90s, which are unique and quite eclectic, and you won't find them anywhere else. And as a special bonus for this year or tonight, if you become an exclusive member before March 31st, you get an additional 5% discount on the conference pre-registration. The conference is August 10th to 14th, and we're working on the final schedule this week, and I hope to have it up by next Sunday. In any case, without further ado, let me bring up Mark. Hello, Mark.
Hello, everyone.
So,
welcome to Steve's Place.
Yeah, glad to have you here. And anyway, if you're ready, let's go ahead and just get right into it.
Okay,
tell us a little bit about yourself real quickly, though. You do the Falcon research or whatever.
Yeah. So the company's name is Falcon Space. My last name's Sokol, means falcon in Russian. And basically what we're doing here is trying to figure out how flying saucers operate, or anti-gravity, reactionless propulsion, warp drive, all of the above, from kind of concepts to explain how a craft can go, up to the speed of light and, do 90-degree turns at 10,000 miles an hour, the kind of stuff that we've seen with the Tic Tacs. And we have quite a laboratory set up over here. And I'm actually in the laboratory right now. And this presentation that I'm going to be talking about today was one that I gave over at Disclosure Network New York. It was actually my first presentation on the topic. So some of the stuff may need to be a little updated since then. Just to give you some sort of overview of what it is we do, and the different concepts and ideas and possibilities of what can be done with anti-gravity. So let's see if I can pull up the slides.
I'm going to go ahead and just go right into your slideshow, okay?
Okay.
Well, here you go. Let me get out of here.
Okay, so first slide is Falcon Space. That's our logo, advancing anti-gravity technology. The way you advance anti-gravity technology is by just trying all the experiments and running through all the theories of how these things work. There's been lots of theories that have been postulated. Some are more promising than others. But I believe, and so does members of our team, people that I've been working with, who I'll mention in a moment, that if we try these experiments and they fail, and we tell everyone why they failed and show everyone, be as open as possible about what happened, we can move forward by learning what doesn't work as well, because there's a lot to learn in stuff that don't work as well as stuff that do work. So our motto is advancing anti-gravity technology. This sign is actually posted on the front of our building down here in Hawthorne, New Jersey, which is interesting because SpaceX is located in Hawthorne, California. We're in Hawthorne, New Jersey, so like to think of ourselves as SpaceX of the East. Also, New Jersey has quite a history with anti-gravity and advanced electronics and stuff. Nikola Tesla was here. Thomas Edison was here. There's lots of history here in New Jersey working on these type of technologies, and we are associated also with the Nikola Tesla Foundation, working with local universities as well to bring students in to work on these different types of technologies. So without further ado, let's get into the nuts and bolts of this presentation. So first question is, what is gravity? Well, Isaac Newton first noticed it, or gave a word for it when that famous apple fell on his head. And it's basically a pulling force that pulls large objects together. It's one of the four known forces in nature. There's gravity. Is there a graviton? We're not really sure about that. We haven't found a particle that is associated with gravity. It extends to infinity. Next force is electromagnetism, which is associated with the photon, with the electron. Those two forces work in tandem. When you have electricity flowing, you have magnetism. When you have magnetism and it's changing, you have electricity. That's how motor generators work. Next force is the weak nuclear force, which is shown with the W and Z boson. It extends less than the diameter of a proton. So these are forces that are within the atom. And basically, as these forces of nature get smaller and smaller, they also get stronger and stronger. And then there's the strong force, which is really in the center of the atom, and that's what holds things together. And by its name, strong force, it's the strongest of the four forces. There may be some other forces, which we can get into in a little bit, but these are the four known, and this is straight up, what you'd learn in any physics class. Gravity is a very weak force, which is strange because it's what's holding us down to the planet. But think about it, it is very, very, very weak in comparison to the other forces. It's a fundamental physical force that is responsible for the interactions that occur between bits of matter and any other piece of matter. So they're always pulling together. We've never seen gravity push apart, or what you'd think of as anti-gravity. We've never actually observed that. Also, force of gravity does not depend on temperature or charge or any other attribute that we can put to it. Spin something up, high temperature, very low temperature objects, they attract each other equally. It's only associated with the mass of the object that will equal the gravitational force. And there's a gravitational constant to a certain amount of matter equals X amount of force. It weakens with the square of the radius. So farther you go out, every doubling of distance, you have a weakening of the gravitic force, and it is 10 to the negative 38 times the strength of the strong force. So it's really down there in the zeros, past the decimal point when you're comparing it with the strong force of nature. Basics of gravity. Copernicus first published his theory of heliocentricity in 1543. Heliocentricity means that the sun is the center of the universe, or they thought at the time, or the solar system at least. And that was called heresy at the time, because the church was in charge of all thought. John Kepler first described the laws of planetary motion in the early 1600s. More heresy. Isaac Newton published his the universal law of gravitation in 1686. That was some more heresy. Gravity follows inverse square relationship with force and distance. Like I said before, farther you go out, it drops off by the square. First measurement of gravitational force was by Henry Cavendish in the 1790s. We all know it's roughly 9.8 meters per second, meaning that every second an object is falling toward Earth, it is accelerating at 9.8 meters faster. Take into account air resistance, you eventually come to an equilibrium that is the free fall velocity. Okay, so Newton's theory of gravity, it's explained over here in this equation. F on the left is the total force that you're going to experience. G is the gravitational constant, which at the time was not known, needed to be calculated later. And then you have the mass of one object, the mass of the second object. R is the distance between the objects. This is a great explanation and mathematical a mathematical way of getting satellites into space, launching things around the moon, but it lacks an explanation for the exact rate of Mercury's perihelion precession. And what we mean by that is Mercury is rotating around the sun, and every year it has a perihelion. Every Mercury year it has perihelion, which is the point where Mercury is the closest to the sun. Mercury's perihelion is not constant. Earth's perihelion is around January 4th, but Mercury's keeps on changing. And why that was, they didn't know at the time. And they didn't even know that that was a problem because of the amount of observations of Mercury at the time that Newton put together this theory. Theory of general relativity came together with Albert Einstein, of course, in the early 20th century. He looks at it in a different way. Gravity is a deformation of space-time. It's an apparent force. But the math really breaks down to the same equation Newton got plus this one over here. And using this equation, adding it into Newton's equations, you're able to calculate the correct orbit of Mercury's perihelion precession. The theory also correctly stated that electromagnetic waves would be affected by gravity, which is why light, which is an electromagnetic wave, bends around the sun. So there was that famous experiment where light was found to be bending around the sun during an eclipse, when we were able to see stars behind the sun, and everyone, screamed that Einstein was probably right about that, but they didn't look at everything else that was going on there in his theory. But basically, his math does break down to the same equation Newton got, just plus one extra piece of math. It's also worth noting that by the time Einstein came up with the theory of general relativity, the perihelion precession of Mercury was already known. There was observations going back about a century and a half, so there was some calculation of exactly what was happening. So you were able to surmise a fix for the equation to figure out what was happening with Mercury's perihelion precession. This equation only it usually equals to zero if any object is not very massive, or the distance is pretty far out, because you see R3 over here in the denominator. That's the distance of the planet from the sun, or from a large object, and that would usually equal to zero. Another large component of Mercury's perihelion precession is actually Venus and Earth tugging on it. So those are also components, things that change up the equation as well. Actually, they're much larger contributions. Tesla had a dynamic theory of gravity. It was never really published, but he claimed to have a complete dynamic theory of gravity that would put an end to idle speculation and false conceptions as to that of curved space. Theory was developed initially between 1892 and 1894 during the period when he was conducting experiments using high frequency and high potential electromagnetism, which is interesting. We're going to get back to that in a second, or in a little bit, because those are the kind of experiments we are working on here, and some things that have been postulated as creating anti-gravity or inertial mass cancellation. Tesla's theory was supposed to explain gravity using electrodynamics. He also famously stated, there's no energy in matter other than that received from the environment. Tesla did believe in an ether. And the Wikipedia page for Tesla's dynamic theory of gravity has been taken down. Again, it has never been published. I think he died before he was able to publish it. So there's that. Quantum theory of gravity is, I think this was brought up with Todd DeCiato, that particles are, and I think Jeremiah Popp also chimed in on this theory as well. Particles are vibrations in the 0-point field that bounce in and out of existence. They're basically these little direct particles that are just vibrations in the ether. Now, large quantities of particles bouncing against the 0-point field cause the 0-point field to become more elastic and less coherent. So think of it as a whole bunch of rubber bands going in all directions, and when you push against them, then they bounce back and forth, and that's where your particle is. So when you have lots of particles, the rubber bands in that area would be much more stretched, right? So a ball bouncing between two plates is a good analogy. Like, think of a ball bouncing between these two rubber bands, and then there's a spot where the rubber bands are more flexible. They would always want to go toward their lowest energy state, falling toward the Earth. So that's a good analogy. Everything wants to go to its lowest energy state. Gravity theory, all particles are electromagnetic fields of different shapes, sizes, directions, and spins. Particles radiate an electromagnetic field that spreads to infinity in different directions, orientations, and spins. The intensity of that field is what dictates the particle's mass. Since all matter is interconnected and nature likes to achieve equilibrium, electrogravity is the result. There was going to be a video after this, but we weren't able to load it, showing how the surface tension of water is a good analogy of that. Water in outer space, it forms a sphere similar to the way planets are. So this is just another way of looking at matter and connecting matter and electromagnetism. We already know that matter and energy are one. That's what E equals mc squared taught us. So this is just another way of looking at it, that they're just different types of spins, and their energy is what dictates their mass. So electrogravity and quantum theory of gravity disagree with general relativity about space-time curvature. They agree with special relativity and an explanation for gravity while unifying all the forces. Explain why light is affected by gravity. And they both offer ways to affect gravity or create artificial gravity. And I will get into that in a moment. So what is anti-gravity? Well, it's the term anti-gravity has been thrown around a lot. When we say it in our in the poster, advancing anti-gravity technology, really we mean however those craft are able to do 90-degree turns at 10,000 miles an hour. Whatever technology it is that's doing it, fine with me. But from the term itself, it seems to connotate a force that opposes gravity. We're not sure if such a force exists yet, whether you can you can detune gravity, or whether you can have an opposing force, similar to the way you have with sound. Sound noise canceling headphones, where you can get out of tune and cancel it out. I'm not sure if that exists yet. Well, one concept was warp drive. Warp drive would be based on, according to Einstein's general relativity theory, gravity's a warp in space-time caused by matter. therefore theoretically possible to warp space in front of the craft using negative matter, and the craft would surf on a continuous wave of warped space. This is based off of Alcubierre, who is a mathematician from Mexico, I believe, who came up with this concept. They call it the Alcubierre drive. And the issue with it is it was highly it was a pretty promising idea. It was accepted by most scientists as a valid theory. Problem is that the standard model of particle physics does not include negative matter, so it's really a no-go as far as producing anti-gravity or getting craft to work. Although there are some variations of warp drive that might work without negative matter. We get into those later. The next thing that has been pretty mainstream in this field is Bob Lazar and his sports model. He claimed to have worked on reverse engineering alien spacecraft at S4 near Area 51. I'm sure many of you have heard that video, seen his videos, and the recent publications. It was on Netflix. It was on Joe Rogan. Propulsion is achieved by amplifying the gravity wave of element 115 and using that to direct the craft. Energy is produced by hitting element 115 with a proton, making element 116, which then produces antimatter, or which is antimatter. I've been having conversations about what exactly he said, which then interacts with a gas that turns it into pure heat energy, which then converts to electrical energy using 100% effective thermoelectric converter. Well, the issue is that as far as we've been able to discern, element 115 is not stable. It was produced in Russia as moscovium, although there may be another isotope of it that's stable. The isotopes that they were able to create were not stable. Also, element 116 cannot be antimatter. You can't take matter and add more matter to it and expect antimatter. Antimatter is on a subatomic level. Like every particle of antimatter needs to be added together. You need an antiproton, an antineutron in order to make antihydrogen. So adding more matter to an element and expecting antimatter is not really realistic. Also, his story is widely available online and shows up prominently in search results, which leads us to the conclusion that it is also a no-go for this field. But there was something very interesting that Bob Lazar stated during his presentations, was that he was inside of the craft, and he said all the seats were small and it looked otherworldly, and he went into the base of the craft, and all of these explanations were fed to him, but this was one part of it that he that he was giving his own take on what he was looking at. He said there was these tubes going through the craft that looked like microwave waveguides, which is kind of interesting because we are working with microwaves over here to try to produce similar effects. Next one is the Q thruster. This was invented by Roger Scheuer as the M drive. He was on APEC and presented on this. It's a cone-shaped chamber that's filled with microwave radiation and develops a thrust. Many independent laboratories have reproduced this effect. It is quite weak, but it is there. Sony White of NASA Eagle Works Laboratory observed a thrust of 1 to negative 20 newtons per kilowatt, even while using a Faraday cage and a vacuum chamber. NASA team's results have not been published in a peer-reviewed journal, but you're able to see them over here. They actually got quite a bit more thrust more recently. Also, China has been working on this as well, and they've classified their most latest results. Okay, now there's some other theories as to ways to create an inertial mass gravity shielding effect. So if you can shield matter from the effects of inertial mass, that would explain how you'd be able to do a 90-degree turn. Because if the craft is almost weightless, it doesn't take much to do those sort of maneuvers. These methods include dynamic nuclear orientation, which is on a subatomic level, you're getting the protons and the neutron spins spinning in the same orientation. Nuclear magnetic resonance, which is another way of creating dynamic nuclear orientation. Another way to do it is EPR, electron paramagnetic resonance. And these involve using a laminar magnetic field or a highly homogeneous magnetic field and hitting the sample at the Larmor frequency or the precession of either the nucleus or the valence electrons. So the valence electrons would be up in the gigahertz. The nucleus would be down in the lower megahertz, depending on the magnetic field strength. But for any normal magnetic field that's achievable, that's usually gigahertz for EPR or megahertz for NMR, nuclear magnetic resonance. That's how MRI machines work as well. They use that concept because when you energize the core of the atom with nuclear magnetic resonance and then shut off the RF, there is a ringing that rings back, and that's able to tell you what molecules are making up the subject. Another way of possibly doing that is the rotating superconductors. This was supposedly attempted by NASA, although we've heard recently from Tony Robertson that they didn't actually complete the experiment. And then finally is the Searle effect generator, which claims to be this all-in-one free energy and anti-gravity machine with a whole bunch of rotating magnets with non-magnetized neodymium pins that are just spinning around in several different circles around a central point. It's supposed to cool down, create energy, and lift off and fly through the ceiling, although nobody's ever been able to replicate all of those effects as predicted by John Searle, the inventor. Okay, so dynamic nuclear orientation, getting back to that, spin state of the electron Larmor frequency is energized in a strong static and laminar magnetic field using gigahertz range RF. So you have a large electromagnet, which is actually right behind me, inside the Faraday cage over here, which you stick a sample in there and you have highly homogeneous magnetic field lines, meaning that throughout the sample you're getting the same amount of Gauss, which is a measure of magnetic field strength, and that causes the valence electrons, the outer electrons, to precess at a precise frequency. If you're able to hit it at that frequency or tickle it at that frequency, energize it, then you're getting into EPR, electron paramagnetic resonance, and you energize it for a little bit, shut it off, and then it transfers that orientation to the core of the atom where the protons and neutrons are via the hyperfine coupling. That's the connection between the valence electrons and the core. So you're slowly building up nuclear orientation, nuclear spin orientation. The energized electrons radiate their energy to the core of the atom. Yeah, like I explained, via hyperfine coupling. Gigahertz RF is then turned back on, and the cycle repeats. And you're doing this hundreds of times per second. It's a couple milliseconds for every pulse, and it depends on the temperature and the material that you're using. Another way to look at this, of why this would create that effect, is gyroscopes. So if you have a gyroscope and you spin it up, if its spin is flat, it would want to stay along that same axis and plane. If you try to change its axes, it starts to rotate or starts to precess 90 degrees to the direction that you tried to change its axes. So if you think of subatomic particles as a whole bunch of electromagnetic energy that's spun up on itself, spinning at the speed of light, and their spins are naturally incoherent. They're completely random. You see the second law of thermodynamics. We have more and more entropy. The smaller things, with every object, there's complete disorder, disarray in nature. So if the spins are all random and going in different directions, and you were to move an object, by proxy, you're going to be changing the spins of those subatomic particles because you're changing their axes as you move it through space-time. This, in turn, causes a change in their spin. So when you take a baseball and throw it, you're actually changing the subatomic particle spins that make up the core of the atoms in that baseball. So that is where the energy of momentum and inertia is stored. But if you were to orient all the subatomic particle spins along one plane and axes, then so long as you're traveling along that plane and axis, you should be free from any of the restrictions of inertia and gravitational pull, because it's perfectly aligned, and the spins would not change so long as the axis is going straight, or it's going along the plane or along the axes. These spins wouldn't change. Just like if you threw a gyroscope exactly along its plane, the axes would stay the same as it moves along. This explains why flying saucers are able to do that 90-degree turn at 10,000 miles an hour, and also why they can't do a barrel roll. You see them flying, they cannot do, like an F-16, it spins over in a dogfight, but they can change their orientation very slowly. And when they do that, they then tend to shoot off along their axes, or along, a line that would be going through the saucer shape at a tremendous rate of speed, which works in well with this theory. So status of the experiment, this was way back in 2020. Right now we are way farther ahead on this. We've run many iterations of this experiment. We have a large electromagnet back there. The RF power is, in many ways, it's too powerful. We have to tune it down because there's a saturation point. We have seen some movement around the when it reaches lower precession. We have seen some small weight loss, and changes in the sample would turn a little bit. We're waiting on some better Gauss meters to better map the magnetic field, make sure that we're have a completely homogeneous field. But the equipment is much better than we have right now. We also got some very pure 5.9, like that's 99.999% aluminum. The reason why you're using aluminum is because it's supposedly a very good retainer for dynamic nuclear orientation, as like energy as a storage device to keep the effect going. This is all based off of Frederick Alzafon's paper, Anti-Gravity with Present Technology. He published it in 1981, right after he filed a patent. He was working for Boeing at the time, and he filed a patent and released his paper thinking that the patent was come through and that the information would be open source already. The patent was denied on I think security grounds, national security grounds, and the paper, since it was already published, they couldn't do anything about that. But we have the paper, and we're working closely with his son, David Alzafon, on getting this experiment done correctly. Daniel Alzafon, I believe, was working on this with George Hathaway at Hathaway Labs, and they also saw some interesting effects. It didn't lose, the 80% weight loss that he promised in the book, or he claimed that they replicated the experiment back in 1994, I believe, and saw 80% weight loss in a 1 gram sample within a second. We haven't seen results that significant yet. Neither is George Hathaway, although they were using ruby as a sample. Ruby is an amalgam of aluminum. And aluminum, by the way, because it's conductive, it's very hard to get RF into it, especially at those frequencies. You have the skin effect problem. So we're working with very thin material aluminum, such as these mylar sheets that I have next to me, which are basically like those emergency blankets. So it's mylar with a very thin layer of aluminum, and we've found the best results are with that. We really need to tune down the power because you don't want to oversaturate the sample. And this is stuff that we need to get. This is from a while back. Nuclear magnetic resonance. So it's similar to what goes on in an MRI machine. Magnetic fields applied. RF in the megahertz range is applied to energize the core of the atom, and then it shuts off, and the process repeats itself. This is being tried by Todd DeCiato in North Carolina. He was doing it with very weak magnetic fields and very low frequency RF. I have to get back to him about what sort of results he's had. Rotating superconductors. So if you all heard of Ning Li and Tony Robertson, were working on this at NASA. So it started off with, while running an experiment using superconductors, Eugene Podklanov, who originally noticed this effect, we call it the Podklanov effect, noticed that someone in the laboratory who was smoking a pipe, and the pipe smoke rose in a column above the superconducting disks that were spinning. So he placed a ball-shaped magnet above the disk attached to a balance. The balance behaved strangely. Then he substituted it with a non-magnetic material, silicon, and the balance still was acting very strange. We found that any object above the disk lost some of its weight. We found that if we rotated the disk, the effect was increased. Also, they also noticed that it was change in RPM in the disk that effectuated most of the effect. Continuing here, a magnetic field is applied to the spinning superconductor with the field line oriented along the axis of the superconductor spin. So field lines are going upward and it's spinning around it. According to Ning Li, this creates a Bose-Einstein condensate, which is where the entire material is of one waveform, similar to what we're trying to do with electron paramagnetic resonance and dynamic nuclear orientation, getting all of the subatomic particles spinning on the same axes, which creates a Bose-Einstein condensate, resulting in a very strong gravitomagnetic field, producing a strong repulsive effect. So Podklanov claimed that there was a 2% weight reduction. In 1993, Li claimed to have a functional anti-gravity device using this method. However, in 1997, Li published a paper describing an experiment that showed the effect was very small, if it existed at all. Ning Li didn't. She went off the map for a little bit. She was suffering from cancer. Has since passed away last year. Tony Robertson was also working on this experiment. He did an update on APEC, where he stated that the experiment was actually never completed, at least not with him. And Ning Li ran off with the disk, so it's possible she got that weight reduction at a later date, and ran it separate without the NASA affiliation anymore. Podklanov claims that she's now working for the Department of Defense and has been in sporadic contact with her. But she passed away. This is an older presentation, so some of this stuff needs to be updated. We have completed a replication of this experiment on air live at APEC. You can view that. I think it was summer of 2021. Right after Tony Robertson did his presentation, we were spinning up some superconductors looking for weight loss. Nothing significant was observed. There were air currents involved that had to be mitigated, but we were using a block of Teflon to measure weight loss, and we didn't see much happen. Also, our disc was nowhere near as large as the 12-inch disc that they managed to create. Ours was more like 2 inches. So the Searle effect generator here, the bottom right, there's a nice little picture of it, or how they would want to create it. It's a bunch of rollers with complex magnetic fields. They're spinning around this core. The white material you see over there is Teflon. I know there's some non-magnetized neodymium that's used in it as well as iron magnets, copper. The coils on the outside are what get everything to spin, but apparently it starts to spin on its own at some point, and the temperature drops, and it starts producing power and weight loss. There's been several teams that have dumped lots of money into this experiment, and none of them got it to work. I'm going actually out later this week to go check out one of those teams and see what they've been able to accomplish with it. But a lot of money has been dumped into the Searle effect generator. It's supposedly this all-in-one effect. Interestingly enough, if you get into ufology, people who claim that have been on board UFOs, nobody's ever claimed to have seen something that looks like this on board a UFO either. So it is a little suspect. We have a team in Vietnam. This is a friend of ours in Vietnam who tried this experiment. He got, I think, 2 or 3 rollers spinning around, and he saw a 3-gram weight loss, although everything is shaking, so it needs to be verified again. You can see the setup over here. Next thing we'll get into is electrogravitics. This is purely high voltage DC or pulse DC. The term was coined in the 1920s by the discoverer of the effect, Thomas Townsend Brown. It's been widely criticized as being a known force, electrohydrodynamics or ion wind. When you ionize air, it creates a wind effect. These are how the lifters work, that we've all seen. Tim Ventura's been very into those lifters. But the effects of ion wind would be down in the tens of grams at best. Later experiments claim to have eliminated ion wind, and in fact, the effect strengthens. He claims that he tried it in a vacuum chamber in France, and the effect got stronger without any air being present. Of course, any engineerable method for anti-gravity will likely be utilizing electricity because it's one of the forces that we have the most control over. It's how we're communicating right now as well. So the gravitator experiment, this is a patent in England, patent number 311. The claim is that it's a way to convert high voltage DC into gravitational potential using highly charged parallel plate capacitors. Now, regular capacitors wound up like a coil. It's like sheets similar to a battery. In a parallel plate capacitor, you have like a prismatic cell where you have a sheet of metal and then plastic and then metal, plastic, metal, or dielectric metal, dielectric metal. And he claims that when you sandwich those up and charge them up to a high voltage of 70,000 volts, they move in the direction of the positively charged plate. And most interestingly, the effect is proportional to the weight of the dielectric. This can't be ion wind because he shielded it from the outside very well, so there shouldn't have been any ion wind effects. We have replicated some variants of this experiment, found that there is lots of ways to make errors when dealing with high voltage. Even if you're shielding something very well, if you charge it highly on one side, the opposite side will get the opposite charge. It's just the nature of a capacitor, and that can interact with the environment. We found that the wires that went into the apparatus, those can produce ionizing ionized wind, which would move things around. There's also electrostatic repulsion, just like two magnets can be attracted or forced apart. High voltage static electricity can produce a similar effect. So there's lots of ways that T.T. Brown could have got this wrong. Another thing that we've looked at is it's possible that the materials that he used in his dielectric were actually contributing to the effect. One of those things is litharge, or was it litharge? It was lead oxide. Yes, lead oxide. So there was oxidized lead inside of a paraffin wax inside of the as a dielectric material to make it heavier. That may have contributed partly to the effect. Oh, so there's another paper that we found that seemed to indicate there actually is something here, and this is a short extract from that paper, the exploratory research on the phenomenon of movement of high voltage capacitors. Basically, they found that there was a force, and the observed tendency was that the charge capacitor consistently moved in an upward direction. However, the force cannot be directly associated with the interaction of electric or magnetic fields of Earth. The results are extremely anomalous. It showed that the upward motion is proportional to the amount of electrical potential energy stored in the electrostatic field of the capacitor. So what they found with their experiments was that the strength of the field was not related to the weight of the dielectric. It was actually related to the strength, the overall amount of joules being stored by the capacitor. Another interesting thing they found was that when they ran this experiment inside of a Faraday cage, the effect was gone. So they presumed from that therefore the effect must be interacting with something on the Earth or something in the ionosphere, something in the environment that a Faraday cage will negate. There's the graphs that were shown with this experiment, and they showed that in some environments they got with a 5 millimeter dielectric. This is extremely thin. At 100,000 volts, they were able to get upwards of 350 grams of weight loss, which is very significant. That's almost a pound of weight loss in a parallel plate capacitor. And for comparison, 100,000 volts for a ion lifter, the most they got was 48 grams with the most efficient setup they could conceive of. So it was unlikely to be ion wind, associated with ion wind. The chart on the bottom left, energy versus force observed. This is energy stored in the capacitor, so it logged nicely with the amount of energy stored in the capacitor versus the force that was observed. We did replicate an experiment similar to this. I wasn't able to get 100,000 volts with a 5 millimeter dielectric. It would always arc over, but the closest we got was about 70,000 using a piece of glass, and we did not see that kind of result. Although it's possible this needs to be ran outside because the building in here does have metal in it, so there might be some shielding effect. So we may have to run this experiment outdoors on a very still day in order to be sure about that. So the way forward, how do we move forward with these experiments? So technological progress comes from doing things differently in an unpredictable way. The future is not an extrapolation of the past. That's from Stanton Friedman. Wise words. Stanton Friedman is no longer with us, so shout out to him. He was a great ufologist who studied some of these concepts at length. We have plans to try another variation of this with the parallel plate capacitor using a thyrotron as a pulsing device. The thyrotron was removed from the Berkeley Labs Linear Particle Accelerator, where it helped helped discover many elements. We've actually since then wired that up and have used that in some experiments as well. When Jeremiah and Jeremy were down here at the lab. So what is happening in this field? Why are there so few people? And there's lots of friends of mine in the chat here as well. It shows it's a really small community. Why is it such a small community? And the answer to that is the Mansfield Amendment in 1973. It restricted research by the Department of Defense for non-military applications, and that included anti-gravity research. And they did this in a roundabout way, saying that anything that goes against the mainstream, status quo is not going to get our funding. Meaning that if you disagree with anything that Einstein said, or Bohm or Bohr, or if you're trying to come up with new physics to explain these phenomena and run an experiment based off of that, you're not going to get funding. So the experimenters usually have to follow the funding. And that's why major universities will not get involved with anything related to anti-gravity, although this is changing these days because of the recent openness on the study of UAP, or unidentified aerial phenomena, which is just another way of saying UFO. And we may be seeing new funding opportunities coming from the Department of Defense or from NASA towards these kind of experiments. And ways to get involved. You can donate time, money, or equipment and supplies. Come down here and help out. We're in Hawthorne, New Jersey. We're always interested in new engineers or anyone who has any knowledge in this, or you don't even have to have knowledge in any of these experiments. Most of the work here is arts and crafts. Most of the work in setting up an experiment is simple arts and crafts. We need out-of-the-box thinkers, go-doers, people who are able to take things apart and fix them. Autodidacts are usually great at this type of work. I don't expect you to have a degree in anti-gravity. There's no such thing. Although we do have a member of the team, Charles Crawford, who will be meeting later this week, who's trying to get exactly that. He's trying to get a PhD in anti-gravity. He's working with the GraviFlyer, which is another device I didn't include in this presentation. And that is pretty much it. And I see we have lots of comments in the comments section.
Well, I'm back.
Hey there.
Yeah, and what we're doing is we're posting our address here. If someone wants to get on the show and ask a face-to-face question, or you can just send a comment right now, and Mark will be able to answer it.
I hope.
I'd like to remind people that Mark will be at our conference this year, right? In Albuquerque. Now's a good time to get signed up for that. And let's see what else I got to do here.
I see lots
of polar line.
I see lots of people that I know. Exact Propulsion. I believe that's Jeremiah Pop. He's been down here at the lab a lot, helped out. Very grateful to him for that. Charles Crawford. He's the guy who's working on his PhD in anti-gravity. Actually, he's down in Dallas, Texas. Alien scientist. Of course, that's Jeremy Reese. There's quite a few people here.
And one of the things I've been doing now, when I first started, like with the Tesla Society, my target has been the academic world. Because if you can't get the academic world involved in this, the universities and that, it's always going to be like a abstract type of deal. You'll be considered for science and that. That's to come. We, in past conferences, I've published proceedings and that. And starting with Tesla, who's probably one of the world's greatest scientists and that. So your goals and our goals kind of like dovetail there. You know, um, I never paid much attention to that Mansfield thing. They may not fund people privately, but I guarantee you that in the back rooms of these Air Force laboratories, in particular, and the Navy, they're looking into this stuff. You know, I'm surprised they haven't come around to recruit you.
Maybe they have, and lots of people have been trying to recruit me
You know,
and other people on our team. We actually got lots of our equipment from Sandia Labs down in Albuquerque, New Mexico, where some of the stuff has been supposedly experimented on back in, you know, starting in the 50s, going well into the 90s. So we got some of their used equipment for a very good deal, and we have it here at the lab. We're using it for our experiments. Actually, it's right behind me. A lot of that equipment came out of Sandia Labs and Los Alamos. Stuff you see right here, literally funded by our taxpayers and then sold on eBay for steel. So we're recycling all that stuff, but getting universities and all those people involved would be great. But bear in mind, the Wright brothers didn't need any universities to get their first craft off the ground.
well, that might be to get the first craft off the ground, but to really make it into an industry, and that's where we really want to be heading, so we don't have to be driving cars with tires on it, and wasting all that rubber, and and to actually get off the planet for
Right,
real.
right. It's one thing proving something in a lab. It's a whole nother thing turning that into an industry and mass producing it for the masses. Those are very different things. And Elon Musk is big on that. You can make one electric car, and you can make it do anything you want, but to mass produce that is a totally different thing. So we will need to get industry involved. We'll need to get the universities involved and the mainstream. And I think the mainstream is starting to head in our direction with with all the recent disclosures by the U.S. government.
Well, I also believe in the secret stream, and that's in the back labs of the Air Force and the Navy. Like when I was an engineering student, in college back in the '80s, okay, way back in the early '80s. Um, I was in Sandia Labs, on a tour there, and they showed us the superconductor there, and they showed us well, like this 12-story truss they had, where they pull these like 747s out there and zap it with the smart generator and everything. They showed us all that stuff. They even showed us the airborne laser, and now it's coming out like, wow, this is the latest thing. No, it's not. You know what they have, we don't really know.
Right? Because they can slap a security agreement on it and keep it secret. And actually, the best way to keep it secret is to keep it in private industry hands. Because FOIA, you can't send a FOIA to Lockheed Martin or Northrop Grumman and ask them for all their UFO data. You could do that to the government, and they'll spin you around and give you redacted reports, but the private industry is much better at keeping it secret than government.
Well, I also think industry has changed. Like I remember when I worked for uh, AMI, aircraft mechanics. We made the seats for the space shuttle. Okay, and I know they had built an extra space shuttle, but they could never get the Rockwell and Lockheed and them. They could never get permission from the government to go ahead and assemble it, and they were going to pay for it and fly it themselves. They could never get the approval from the FAA for that. Now look at what you got. You got SpaceX and everybody and their brother out there launching rockets. So things have changed dramatically. You know,
Um,
and
definitely has. Jeremiah also mentioned we're not just a lab over here in Hawthorne. This is like a full-fledged makerspace. We got a CNC machine, pretty powerful capabilities, a full machine shop for whatever kind of experiment you'd want to try. So if anyone has some idea of their own that they want to try out, you can come down here and help out, and we'll help you work on your experiment. We've had independent researchers come down to the lab in the past on multiple occasions, and we're glad to help them out, build their experiment out and see what happens with it. Also, we do have a Marx generator over here right to my right. It's 1 million volt spark. Right over there, it's that big tower. Me and Jeremiah built that back in the end of 2020, I believe. That was that's able to put out like almost 1 million volts. They call it the megavolt Marx generator, and that can pack a punch. Over here we have this power supply puts out 15 kilowatts of power at 12,000 volts. That's for running different klystrons. So we definitely got the power. The building is rigged for it. So whatever kind of experiments you want to run, we could probably do it here.
Well, here we have one of our guests here, the crypto alchemist.
Oh, I know this guy.
Hello. Bernard, Kronk, and Steve, nice to finally meet you. I've sent you a few emails, I think, a little bit ago. But big fan of all your work. Nice to see you on here, Mark.
Thank you.
I was thinking Jeremiah, Jeremy, and Mike might join, but guess I'm the first.
You're the first ever. We've been trying to get it to have a video question session or whatever. Yeah. So, have you ever met Mark before? Or?
I've talked several times on APEC and whatnot, but never in person. I'm stranded up here in Canada, so we've only got to know each other recently since the lockdowns. But big fan of the work. Big fan. Mark, just wondering, have you talked to Michael Esoteric Gold there yet about getting any of his monoatomics to experiment with?
Thanks for reminding me. Yeah, I'm actually in contact with him, and I need to reach out again to see what kind of materials he has. I've been inundated with some personal stuff and some lab stuff recently, so I haven't been able to reach out to everyone. But yeah, I'm starting to see the light that these kind of experiments with EPR, they may need, the monoatomics or the very thin layer materials that Jeremy Reese has been talking about for a long time, because the skin effect of RF at those frequencies is just so damn thin. So you need to really thin down your materials in order to get these effects.
Definitely, and it seems that more and more it's all about the specialized nano materials and getting them into and of course I get a brain fart right when I need to say something. The terahertz, but the wow, can't even think of it.
Are you talking about terahertz band gap?
The waveguide generating in the nanoscales with those monoatomic or nanomaterials and the plasmoids and whatnot. Basically connecting Bob Greenier's work with Martin Fleischmann project and Moray B. King's work with all of the monoatomic and plasmoids and whatnot through electrolysis. Very, very good stuff. And then it's just a matter of putting it into the 3D printers and making it into those waveguides to be able to harness it properly. I believe you were talking about that, Mark, a couple of APECs ago.
Yeah, it's possible. We're talking about lots of stuff.
Very true. I was hopping on hoping others were going to too, and now I'm just kind of put on the spot. But me and Jeremiah actually did a stream together a few days ago, and he was able to replicate making monoatomic bismuth out of bismuth and bismuth anode cathode in some salt water with only 5 volts, and was able to get an entire bar in our stream to turn into the pure white monoatomic, no oxidization or anything.
That's bismuth oxide, or is that bismuth pure?
Just pure bismuth. When it oxidizes, it always will turn blue or green like this, and then it's diatomic instead of monoatomic. But you can see how it starts going wavy as I hold it up. I've noticed that all of these different plasmoids will create this plasma field with any video or camera where it gives this interference. And it's quite fascinating. The bigger the light you hold on it, the more the interference wave happens. Oh, now it's not doing it. Oops. Oh no, I'm not gonna do it. Oh, is it flashing? No, not this one. Oh, he's on the spot. Never works, right?
So who does your artwork? Is that your work?
Yeah. So I've all pieces I've commissioned over the years. I do festival clothing and different art prints and whatnot vending. But yeah, lots of different artists that have painted them for me over the years. But definitely figured I should highlight the Tesla for your Tesla Tech channel, and then
Yeah.
good old Einstein in the background too.
Wow.
Yeah, nice to meet you finally, Steve. So I've been doing working with the Keshi Foundation, doing my own experiments with some of their work over the last decade, and then connecting it through the electrolysis into cold fusion alchemy from Sir Isaac Newton's recently released alchemy writings. And I've been able to reproduce all 7 transmutational states of the metal elements that Sir Isaac Newton describes, and I've been able to do it with over 10 different metals now. So I highly recommend people looking into that work, because there's also a lot on light and how light and color affect or transform into the different energies that are contained in his alchemy writings too, not just his regular physics.
Bernie, I might cut you off. I may need a sample of that monoatomic bismuth, or at least maybe a discussion of how to produce it. Got lots of bismuth here at the lab, but there's lots of experiments I want to try with bismuth in that form. Jeremiah also mentioned something that I forgot to talk about. Warp drive in the form of standing electromagnetic waves, because electromagnetic wave is basically pushing against space-time, and space-time pushes against it, pushes back, and then that's where that bounce comes from. You know, the vibration allows it to move through space-time. That's why we're seeing light, you know, from the sun, with the medium being space-time or the ether. But if you're able to create a situation where the waves, the electromagnetic waves, are standing, meaning that they're not just constantly moving, they're actually creating a constant warp in one spot. You can change the permittivity and permeability of space-time, and that is permittivity and permeability are the epsilon and mu, or the amount of electrostatic charge that you're able to put into space-time, and the amount of magnetic strength you're able to put into space-time, which dictates the speed of light. But by putting energy into space-time through that standing wave and keeping it coherent in one spot, you're able to change the refractive index of space-time and have a way of pulling on, you know, or interacting with space-time directly. So you might call it a warp drive. It's probably the closest term to it. But that's another thing that we're looking into. I actually have in contact with a team in Florida that achieved about 100% weight loss in their engine. This is similar to what PNN is doing out in Italy and what Quantum Electrodynamics is doing out in, I think it was Omaha, Nebraska. But he achieved actually 100% weight loss just in the engine itself. That's not including the RF generators and everything. Just using electromagnetic standing waves.
That's pretty impressive right there.
Yes, yeah, it is pretty impressive. Question is whether this is a gravitational shielding or whether it's just a straight up propulsion system. You know, those are things that need to be looked into. But for now, setting it on a scale, turning on the device, seeing 100% weight loss in a 2 kilo sample. We're talking about 4.5 pounds of mass disappearing.
That's huge.
Weight disappearing just from use of electromagnetic waves at their standing waves. These are microwaves because the device was like about that big, so we're talking about 8 gigahertz to create that effect.
Yeah, one thing also, once I know you're busy with a million different projects all at once, but what really fascinated me with the Keshi space program is once they get the monoatomics, they put them into a tetrahedron shape of 6 different ones rotating at high RPM in like a tetrahedral form of each other. So they call it the star formation. But bismuth is one of the big aspects that they say once you're rotating it at over 4,000 RPM in this monoatomic form, it starts producing this anti-gravitational plasma field with it. I've not done it myself.
It's very interesting that you mentioned that because bismuth is, for those who don't know, is the strongest naturally occurring diamagnetic material. So when you apply a magnet to it, it repels the magnet. It's a very, very interesting effect. Also, element 115 is the next element on that in that same family after bismuth. So if there is a steady state of element 115, if there is an isotope that's steady, we can expect very interesting properties from it because it follows bismuth.
Well, that's a very good point, actually, Mark. Have you taken a look at Walter Russell's periodic table, the vortex-based one? It's in octaves, but it would essentially kind of support what you're saying there in how the families go in the octaves and in their range of placement. Yeah, so this is monoatomic copper and zinc combined in this one. And it's always like this fluffy pure. And Isaac Newton, in his alchemy writings, states that all metal elements can be broken down into their most basic form, which he calls a single white mercurial form, but I believe that to be Old English for molecular form. But he states that all metals can be put into this pure white single atom monoatomic form, which I believe is plasma state matter. So it's metal elements in their fourth state of matter, the plasma state. Just as your noble gases, when they're ionized, turn into a plasma state, emitting light and whatnot. It's that these metal elements in this single atom state are plasma, as David Hudson calls it, ormus, orbitally rearranged electron molecule, and the Keshi Foundation calls it GANS, gas, atom, nano, solid state. So they're both acronyms for a single atom or monoatomic form.
Okay, thank you, Bernie.
Yeah, sorry.
Okay, so I guess we'll call it a night, huh?
I'm good to go. Got any
Okay,
more questions?
and I'll see you at the conference.
I'll
I
see you.
just want to remind everyone that if they do sign up before March 31st for the conference for the our channel, our YouTube channel membership, which is $9.99 a month, you can get an extra 5% off the conference registration. And I hope to see you all there. And you were there last time. Did you have a great time?
Oh, I loved it. It was.
Yeah.
I've been to a couple conferences before and since. Your conference is the nicest. The people are genuine, and the food is great. It's a great atmosphere, a great environment, and we're right there in Albuquerque, New Mexico, right next to Sandia and Los Alamos Labs. It's a road trip away from the Roswell crash site. Me and Jeremy Reese actually drove down. It really is its own world. It's
Anyway,
nothing to be missed.
so anyway, I'll see you. I'll be in touch with you later on this week, and I'll see you at the conference for sure.
Okay, thank you.
And thank you all for coming, and that's call it a wrap. Thank you.